Okay, let's proceed to the next method to solve the system of linear equation of ax in the form of ax equals to b, which is by using the elimination method. So we have two types of elimination method, which is the first one is Gaussion elimination method. The other one is Gauss-Jordan elimination method. So let's take a look what's the difference between these two elimination methods. Okay, the first one for the Gaussion elimination methods. The first thing first, before we reduce in the form of that needed, we have to convert the equation of ax equals to b, and we have to rewrite it in the form of augmented matrix, which is A augmented with B. Okay, this step is the same with Gauss-Jordan elimination method. You should start with this augmented matrix, which is A augmented with B, and then we're going to reduce in the form of this one. Okay, this is how we're going to start it. Start with, which is A augmented with B, reduce by using ERO, elementary row operations, until we get in this form, E augmented with C. So what does it mean by E? E is actually in the form of matrix in the form of upper triangular matrix. So upper triangular matrix is actually in this form, which is these three elements should be in zero value. So this is what we call as an upper triangular matrix. So meaning that here all of this element is not consist of zero. Okay, so you have to make it after we reduce by using ERO, you have to make sure you get in this form, and then we're going to proceed with the next procedure, the next step. Okay, for the Gauss-Jordan elimination method, okay, you should start with the same thing, A augmented with B, reduce by using ERO, elementary row operations, until you get I augmented with X. So I means that the identity matrix of the square matrix that we are looking for, augmented with X. X is the solution. So you have to make sure that your left part of the augmented matrix is in the form 1 0 0 0 1 0 0 0 1, and this is your solution. You get the solution for this part. That's the difference between Gaussion and Gauss-Jordan elimination method. So let's go for the example. Right, so the example 18, solve the following system of linear equation using Gaussion elimination and Gauss-Jordan elimination methods. So you are given the three linear equations, so you have to convert it first in the form of ax equals to b. So it means that we're going to write it as a 1 negative 3 1 1 1 1 2 negative 1 1, multiply with the x, which is variable involved here, x y z, is equals to the constant value here, negative 12 0 negative 8. This is in the form of ax equals to b. Okay, after that we're going to rewrite it in the form of augmented matrix A augmented with B. So A augmented with B, A augmented with B. This is the form that we should start with. So the A is 1 negative 3 1 1 1 1 2 negative 1 1, augmented with B, which is negative 12 0 negative 8. Okay, so we have done for the first step of doing the elimination method. Okay, so what we need to do is we're going to reduce this form, this augmented form, by using ERO. Elementary row operation is just the same with what we have learned from the finding inverse by using ERO, but the difference is the previous part is finding the inverse. This one is the part of we are going to solve for the x, y, and z. That's the difference between ERO and the eliminations method. So we're going to reduce it in the form of this is what we call as upper triangular matrix. Okay, upper triangular matrix means that we are looking for the 0, 0, 0 for these three elements. Okay, and then we're going to stop the process of ERO and then proceed with the other process. Okay, so maybe we're going to start with labeling all the row here, which is this is the first row, label as A, B and C according to its row. So A for the first, B second, C for the third row. Okay, so we are focusing on the first column, which is the element for the first column that need to be changed becomes 0 is for the row B and also for the row C. Okay, these two elements need to be changed become 0 by doing the process of elementary row operation. Okay, so the row A, the array will be the reference value to do the operation. Okay, so we're going to start with changing the second row, which is changing the row B. Okay, so row B is the second row. Alright, so we're going to take out the A and B, stand for the row A and row B. Right, so the element for the row A and row B for the first column is 1, and then for the B also 1, and then you just cross like this, and then you will get A minus B. This will give you the new second row. Okay, this will give you the new second row. Right. Alright, so we've got the first operations, which is operation of getting the second row, the new second row, and then we're going to change the third row by taking the A as a reference value. So A will be with C, so it means that the value here should be 1 and 2. Okay, the element for the first column for the row A and C. So you're just doing this way, and this you get 2A minus C. Okay, to multiply A minus C, so this will give you the new R3, the new third row. Right, so by referring to these two operations, so you have to calculate it until you get the new second and third row. So the first row will be the same with the starting augmented matrix, which is 1, -3, 1, -12. There's no changing in the first row. For the second row, you're going to get the new one by using this operation, which is A minus B. So you just do it by using the calculator, and then you get the new element here, which is 0, -1, 0. And this one become -12. And then also for the new third row, which is 2A minus C, just calculate by using the calculator. So you get 0, -5, 1, -16. So here we can see that we have done for these two elements, in order to make sure that these two elements become 0. So we have done for these two elements, and now we're focusing on the second column. Okay, second column, the element that we are focusing right now is the last row, which is -5. This -5 need to be changed become 0. Okay, so just repeat the same process. So make sure you label first. This is the row A, B and C. So row B will be our reference value, which is the operation here is we're going to pair B and C, which is the element for the second row here is -1, -5, and then you just do it the same process. So you get -5B minus with minus C, so you get 5B -5B minus with, okay, sorry, this is slightly a mistake. This should be -4. Okay, this is typo here. This is -4. This should be -4. Okay, so this one will become -5B minus with -4, so plus with 4C. Alright, so this will give you the new R3. Okay, R star means that the new R1, the new R3, the new row that we are looking for. So then you have to calculate it. Okay, so meaning that we are only changing the third row. So the first and second row will be the same. We just maintaining the same element for the first and second row. Okay, you just copy down from the previous part. Okay, so the third row will be the new one. So you have to calculate by using your calculator, and you get the new one, which is 0, 0, 4, -4. So now we have done for this part that need to be changed become 0. So and then you stop the process of ERO. Okay, you just stop, and then we proceed with the next step, which is we just take out all this element and forming the equations. Okay, you just need to rearrange the equation, and then you get x, y, z. Okay, so we are going to start with the last row. Okay, so the last row, when we converting into the equation form, okay, it's mean that this is mean that 4 is actually multiplications of the last variable. So this is for the x, this is for the y, this is for the z. So when we focusing on the last row first, meaning that 0 multiplied with x plus 0 multiplied with y plus 4 multiplied with z is actually equals to -4. So from here, 4z is equals to -4. So then you get z is equals to -1. So we've done for the value of z. Okay, and then you're going up here, focusing on the second row. Okay, you should start with the last row, and then the second row, and then going upward for the first row. Okay, that's the what you call it, that's the step that you have to follow. Okay, you shouldn't start with the first row, because when you start with the first row, you're not going to solve for any variable yet. Okay, you should start from the last row first. Okay, and then for the second row, okay, you can read it as a 0 multiplied with x. Okay, -4 multiplied with y, which is -4y, plus 0z. It's just a coincidence that this element is 0. Okay, equals to -12. So meaning that is -4y is equals to -12. So y is equals to 3. And the last step is for the first row. So the first row is x minus 3y plus z is equals to -12. So since we already have the value of x, the value of y and z, so you just need to substitute. So x minus 3 multiplied y is equals to 3 plus z. So z is -1, so -1 is equals to -12. So x, you get -2 as the final answer. So now we have done for solving the system of linear equation by using Gaussian elimination method. Alright, so now we proceed to the second, the other elimination method, which is Gauss-Jordan elimination method. So what's the difference between these two things? Okay, you should start with A augmented with B. So we're going to reduce by using ERO until you get the identity augmented with x. So this is the solution that we are looking for. Okay, so you have to reduce until you get the identity parts for the left side of this augmented matrix. Right, okay. So for sure we have the same beginning from the same beginning with the Gaussion elimination method, which is in the form of A augmented with B. So you just copy down for A augmented with B, which is 1, -3, 1, 1, 1, 1, 2, -1, 1, augmented with -12, 0, -8. So you just do the same thing with the Gaussion elimination method. Okay, by labeling, this is become A, B, C. So you just do the same thing. So since the first a few steps of this actually the same with Gaussion elimination, so I'm going to copy paste. Okay, copy paste. So I'm going to copy this part and paste it right here, since we already done from the previous part. So I'm just copy down here. Okay, so let's take a look at what we have done. Okay, let's get started. Okay, this is what we should start, which is A in the form of A augmented with B, and then we're focusing on the first column. Okay, the first column that need to be changed is for the second and the third row. This is the thing that this is the same step that we've done for the Gaussion elimination methods. Okay, so you just do the same process. It's exactly the same with what we have done before it. So I'm just go through a bit about it. So then you will get the new one. Okay, then you get the new one. So this step is still the same with what we have done for the Gaussion elimination method. Okay, so for this part, it's going to be a bit different from the Gaussion. Okay, so when we're focusing on the second column, the elements or the row that need to be changed is the first and the third row. Okay, it's different from the Gaussion. Okay, Gaussion elimination method, for the second column, you just need to focusing on this element, which is the third row. But for the Gauss-Jordan, you have to focusing on these two elements that need to be changed become 0. That's the difference between Gauss-Jordan and Gaussion. So you have to put an extra work here. Okay, this is the same thing that we have done from the Gaussion. So we just need to add another step, which is B a pair with A, because the row A need to be changed. So the element for B is -4, the element for A is -3, so you just need to cross multiply it. So you get -3B minus with -4A. So it means that you have to plus with 4A. So this will give you the new R1. Okay, R star. Star means that you are telling the other people that this is the new one. Okay, the new row. So meaning that this step you're going to get the new R2 and the new R3, the new row 2, the new row 3. So the first row will be maintained from the previous part. So you just copy down 1, -3, 1, -12. So we're not going to change anything for the first row. So the second row will be the same with from the Gaussion elimination method, which is because we are using the same operation. So here you will get 0, -4, 0, -12. Okay, for the new R3, just calculate it by using this. You call it this operation. So then you will get 0, 0. Sorry a bit. There's a I'm so sorry. There's a big mistake. Okay, a big mistake here. All right. So I repeat. Okay, I repeat. the row that not be changed at all is actually the second row. Okay, the second row won't be changing, because the row that we are going to change is the third and the first one. Okay, so just now is a mistake. I'm telling you the wrong one. So just maintain the second row, which is 0, -4, 0, -12. So we are getting the new R1 and the new R3. So the new R1 that you will get is 4, 0, 4, -12. And the new R3, which is the same with Gaussion elimination method that we have done before this, which is 0, 0, 4, -4. So now we get the new one. Right, then we're going to proceed with the third column. So the third column, element that need to be changed become 0 is actually the first and the second row. But since this is just a coincidence that after we have done the previous part, this is already 0. So you don't have to change it. Okay, you just let it become 0. So for this step, you just need to change the first row only. The second row, no need, since this is already become 0. Okay, so the reference of row here is C. C will be this difference row. So C and A is actually our row that we have to change it. So C together with A. So C is a 4. This is also 4. So just repeat the same process. So positive 4C minus 4A. So this is the new R1. Okay. So meaning that the second and the third row will be the same. So you just copy down -4, 0, -4, 0, -12, 0, 0, 4, -4. For the first row, you get the new one, which is -16, 0, 0, 32. Okay, so we are reaching to the finish line, but not yet finish line. Okay, so we have making everything that need to be become 0, that need to be 0 become 0. So we have done for the 0 part. So now we're focusing on the diagonal entries. So the diagonal entries for this matrix right now is -16, -4, and 4. So you have to change it become 1 in order to make sure this matrix become identity. So means that you have to change every single row here. Okay, so for the row 1, for the first row. So the first row, what we need to do is, in order to make sure that -16 become 1, so you have to divide it by -16. Okay, so in order to get the new R1, the row A need to be divided by -16. Okay, for the second, to get the new second row, okay, in order to make sure that -4 become 1, so you have to divide it by -4. Okay, the row B need to be divided by -4. So in order to get the new R3, since this is 4, element 4, so you have to divide it by 4. So then you will get the new one, which is 1, 0, 0. So every single row need to be divided by -16 and -16. So then here you get -2. The second row need to divide it by -4, so you get 0, 1, 0, 3. And the last row need to be divided by 4, so 0, 0, 1, -1. So we have done in process of reducing from the augmented matrix A augmented with B to identity augmented with, this is the identity augmented with X. Okay, so this X is actually our solution. This is the X, Y, Z. So just take out this the final answer, which is X equals to -2, Y is equal to 3, Z is equals to -1. So we've done for the solving the system of linear equation by using Gauss-Jordan elimination method. Example 19, Azro, Siva, Chong bought the tickets for the 3 separate performances the table show the number of tickets bought by each of them. So Azro bought 2 concert tickets, 1 orchestra and 1 opera. Siva 1 concert tickets, orchestra, 1 orchestra, 1 opera tickets. Chong 2 concert tickets, 2 orchestra, 1 opera tickets. If a total cost for Azro was 122 ringgit, for Siva 87 ringgit, Chong 144 ringgit. So here should be 122 ringgit for Azro, Siva 87 and Chong for 146 ringgit. Represent this information in the form of 3 equations. So this is the first part of the question. The second part of the question, find the cost per tickets for each of the performances using Gauss-Jordan elimination method. And the last question asks for the how much it will cost for Khaira to purchase 2 concert tickets, 1 orchestra and 3 opera tickets. So we have 3 instruction of the question. So we are answering the first part of the question, which is forming 3 linear equations. So since the question itself doesn't state what notation that represent what variable that can be used to represent the cost per ticket for concert, orchestra and opera. So you can use which notation that you prefer. So maybe we can use X, Y, Z to represent. X would be the cost for concert tickets. Y would be the cost for orchestra. Z would be a cost for opera. So we're going to use the variable X, Y, and Z. Okay, so to form the 3 equations, so means that Azro bought 2 concert tickets, so we have 2x plus 1 orchestra ticket, so plus y, plus 1 opera ticket, so plus z is equals to 122. So and then that is for the Azro. Siva 1 concert ticket, so x plus y plus opera 1, so plus z is equals to 87, and last one 2x plus 2y plus z is equals to 146. So we have answering the first part of the question, which is forming the 3 equations. So this is our system of linear equation that we want to solve it for the part B. So this is the A, and we're going to proceed to part B. So finding the cost per tickets for each of the performances using Gauss-Jordan elimination methods. So in order to use the Gauss-Jordan elimination methods, so we're going to start with the AX equals to B. So 2, 1, 1, 1, 1, 1, 2, 2, 1 stand for the matrix A. Multiply with X, which is X, Y, Z, is equals to 1, 2, 2, 87, 146. So this is in the form of AX equals to B, and we're going to rewrite it in the form of augmented matrix A augmented with B, which is 2, 1, 1, 1, 1, 1, 2, 2, 1, augmented with B, 1, 2, 2, 87, 146. So this is the A augmented with B. So we're going to start to use the Gauss-Jordan elimination method. So we labeling each of this row by A, B, C, using the A, B, C to represent each of the row that we have. So then we're going to start it by locating which element that need to be changed. So focusing on the first column, which is the second and the third row, element of the second and the third row for the first column need to be changed, become 0. So we just circle these 2 elements, and then we're going to proceed by forming the operation that needed to form the new R2 and the new R3. So the first row, which is row A, would be the reference row to to gain the equation that needed to form the new row for the second and the third row. Alright, so to change the second row, we're going to use the row A and also row B, because A is the reference row. So the element of row A is 2, the element for the row B is 1. So you just copy down here and then you just cross multiply, and you get A minus 2B. Okay, that will give you the new R2. Okay, and then the second one, to change the third row, so we're going to use the A and C. So A is 2, C is 2. So just repeat the same process. So we're going to get 2A minus 2C. So that will give you the new R3. Alright, so we're going to write on the new matrices that we can form from using these two equations. So the first row just maintain from the previous one, so 2, 1, 1, 122. And the second and the third row, we're going to get the new elements, which is 0, negative 1, negative 1, negative 52. This is what you're supposed to get from the operations that we have formed from the previous part. You can calculate by using the calculator. So then we finish up for this first row, and now we are focusing on the second. We have finished up the first column. So then we're focusing on the second column. So for the second column, the element that need to be changed become 0 is the first row for the element for the first row and the last row. So the second row will be the reference row. So this is the A, B, C. Right, so just do the same thing. So we're going to change the A, so it means that the reference will be B. So B with A, so the element of B is negative 1, A is 1. So just cross multiply and minus between these two things. So B minus with minus A, so you get B plus A. This will give you the new R1. And then for the new R3, so the new R3, B together with C, so negative 1, negative 2, just cross multiply, so negative 2B minus with minus C, so you get plus C. So that will give you the new R3. Okay. So for this new augmented matrix, the second row just be the same with the previous one. So you just copy down negative 0, negative 1, and negative 52. And then find out the new R1 and the new R3. Okay, by using the calculator. So this is what you should get. 2, 0, 0, 70. And the last row you should get 0, 0, 2, 56. So now we have done for the first column, second column, and now we are focusing on the third column. So the third column, for the third column, the element that need to be changed to become 0 elements would be the first row and the second row. So since the first row is already become 0, so you don't have to change anything on that. So you're just focusing on the second row. Right? So we are proceed with the next page. So you just need to change the second row. So A, B, C. So the reference row should be the C. So C together with pair with B. So this one should be 2 and negative 2. Just cross multiply with this thing. So negative C minus with 2B. So that will give you the new R2. Okay, the new R2. Right. So meaning that the first and the third row just be the same from the previous one. So you just copy down to 0, 0, 70, and the last row 0, 0, 2, 56. Okay, so you just need to change the second row. So the second row that you should get is, the element here should be 0, 2, 0, 48. Okay, so up to this step we have done for the step of making all the elements that need to be 0, which is the first, for the first column the second and the third row should be 0. The second column, the first and the third row, that should be 0. And for the third column, the first and the second row, that should be 0. So we have make it everything except the diagonal entry become 0. So now we are focusing, the last step is focusing on the diagonal entry that need to be changed become 1. So since each of this diagonal entry is by the value of 2, so means that for each of the row here need to be divided by 2 in order to get the element of 1. So to get the new R1, so you have to divide it by 2 for the A. This is A, B, C. The same thing goes for the new R2, getting the new R2, so 1 over 2 multiply with B, or B divided by 2. So in order to get the last row also, the row C divided by 2, or 1 over 2 multiplied with C. So every single terms need to be divided by 2. So you get 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1. 70 divided by 2, you get 35. This one you get 24. 56 divided by 2, so you get 28. So you have done reducing from A augmented with B. Okay, become identity augmented with X. So this is the identity, this is the X. So means that this is your X, Y, Z. This is your solution. So X is equals to 35 ringgit. Cost for the concert tickets. Y is 24 ringgit for the orchestra. And then Z is 28 ringgit for the opera ticket cost for each of the tickets. So we have done answering for the second part of the questions. Okay, C, determine how much it will cost for the Kyra to purchase 2 concert tickets, 1 orchestra and 3 opera. So means that for the Kyra, cost for the Kyra would be 2 multiplied with X plus 1 multiplied with Y plus 3 multiplied with Z. Okay, so means that 2 multiplied with 35 plus 1 multiplied with 24 plus 3 times with 28. So you can calculate it. So at the end you will get total cost for the Kyra to purchase all of this ticket is 178 ringgit. So we've done for this example. Let's move on to the next part of the we proceed to the last method to solve the equation of system of linear equations. Okay, let's proceed to the next method to solving the system of linear equation, which is using Cramer's rule method to solve for Ax equals to B. So basically Cramer's rule is a method that uses determinant to solve the system of equations. So we're going to start with the list of the system of linear equation and rewrite in the form of Ax equals to B, and then we're going to find out the determinant of the determinant of matrix A. We're going to start with the finding the determinant of matrix A, which is the matrix A comes from the coefficients of each variable. And then after we find out the determinant of matrix A, we're going to find out the D of sub X, D sub Y, and D sub Z. Okay, so what is meant by D sub X? So D sub X is the determinant of the matrices which is we replace the first column with the constants from the equation itself. So it comes from the matrix B. So we're going to replace the first column of the matrix A with the matrix B, which is the constant from the equations. Okay, and then we proceed with finding its determinant. The same thing goes for the D sub Y. D sub y is determinant of matrices with replacing the second column with the matrix B. Right, so we're going to replace with the matrix B. And then lastly, D sub z. So D sub z is determinant of matrix by replacing the third column with the matrix B. Right, and then after we find out all of these determinants, we're going to solve it, which is x is actually d sub x over t. T is actually determinant of matrix A. And y is equals to d sub y over determinant of t, which is t is determinant of A. And for z is equals to d sub z over t. T is actually determinant of A. So we're going to discuss the last example for this topic, which is example 20. Solve the following system of equations using Cramer's rule method. So you are given three linear equations, so you have to rewrite in the form of ax equals to b first, which is you're going to have 1, -3, 1, 1, 1, 1, 2, -1, 1, multiply with x, which is the variable listed here is x, y, z, is equals to a column matrix for the constant value -12, 0, -8. This is in the form of ax equals to b. So we're going to proceed solving for this equation by using Cramer's rule, which is x is equals to d sub x over t, y is equals to d sub y over t, and z is equals to d sub z over t, which is d is actually equals to determinant of A. Okay, or you can rewrite it as x equals to determinant of A sub x over determinant of A, y is equals to determinant of A sub y over determinant of A, z is equals to determinant of A sub z over determinant of A. You can rewrite it in this form also, or you can just use the d of d sub x over d, d sub y over t, or d sub z over t. Is up to you. Okay, so we're going to start with finding the determinant of A. So determinant of A, so we're going to take out these things. So the determinant of A is determinant of 1, -3, 1, 1, 1, 1, 2, -1, 1 is equals to, this is the determinant of A. Okay, is equals to, if you use the expansion of the first row, so means that here should be positive, negative, positive. This is the alternate sign for the sign of cofactor, which is you're going to write it as a positive 1, multiply with, delete the first row and the first column. So this is okay, you have to delete this row and this column. Okay, and you will get the remaining elements here, which is 1, 1, -1, 1, minus -3, multiply with its minor by delete its row and its column. So you get 1, 1, 2, 1. And lastly, plus with 1, multiply with its minor and delete its row and column. So you get 1, 1, 2, -1. So you have to calculate. So 1 should multiply with the 1 multiply with 1 is, and then minus with 1, -1 multiply with 1. So you get 2 here, plus 3 times with 1 minus 2. So 1 minus 2 gets -1. You will get -1 here, plus 1 multiplied with negative 1 minus 2. So you get negative 3 right here. So 2 minus 3, so you will get negative 4 as a determinant, as the value for determinant of matrix. So we have done for the determinant of matrix A itself. So now we proceed to finding the T of D sub X. So D sub X is actually determinant of matrices by replacing the first column with the B, matrix B. Okay, we're going to replace it by becoming negative 12, 0, negative 8 as the first column. So the second and the third column will be the same things with the matrix, the same element with the matrix A. Then you have to proceed with the procedure of finding the determinant. So as the common things that done by students, we're going to use the expansion of the first row, which is the positive, negative, positive here. So then you get positive of negative 12 multiply with its minor, delete its row and column, so you get 1, 1, negative 1, 1, minus with negative 3 multiply with its minus with the remaining element after you delete its row and its column. So you get 0, 1, negative 8, 1 plus 1 multiply with 0, 1, negative 8, negative 1. Then you calculate. So negative 12 should be multiplied with 2 because 1 minus negative 1 plus 3 multiply with 0 minus negative 8, so you get 8 here, plus 1 multiply with 0 minus 8, so you get 8 also here. Then you get 8 as the value for T sub X. And then we're going to proceed with D sub Y. Right, D sub Y is determinant of matrices A by replacing the second column, the second column with the matrix B. So here we're going to have the first column the same with the matrix A, which is 1, 1, 2. The second column need to be replaced by negative 12, 0, negative 8. And the third column is the same element with the matrix A, which is 1, 1, 1. Okay, so this is the difference. This is the different elements from the D sub X, D sub Y, and also D sub Z. Okay, so we're going to proceed with finding the determinant. So here should be positive of 1. This is positive, negative, positive. Positive of 1 multiply with 0, 1, negative 8, 1 plus 12 times with 1, 1, 2, 1 plus 1 multiply with 1, 0, 2, negative 8. Alright, so we're going to calculate it. So 1 times with 0 plus 8, so you get 8 here plus 12 times with negative 1 plus 1 times negative 8. So that will give you negative 12 as the value for T of sub Y. Right, so then we're going to proceed with D sub Z. So D sub Z is 1, 1, 2. The second column is the same with the matrix A, which is negative 3, 1, negative 1, but different with the third column that need to be replaced by the matrix B, which is negative 12, 0, negative 8. So we're going to proceed with finding its element, its determinant. So should be, this is positive, negative, positive. So then you get 1 multiply with 1, 0, negative 1, negative 8. Negative of negative 3 multiply with 1, 0, 2, negative 8 minus 12 times 1, 1, 2, negative 1. Right, then we have to calculate it. So 1 multiply with negative 8 plus 3 times with negative 8 minus 12 times with negative 3. So you get 4 as the value for t subset. And finally, our answer should be x is equal. So x is equals to d sub x over d, which is also equals to determinant of E. So we get x is equals to d sub x. So d sub x is 8, need to be divided by negative 4. So 8 divided by negative 4. So you get negative 2 for the solution of x. So y is equals to d sub y over t, which is equals to d sub y is negative 12. Negative 12 divided by negative 4. Therefore, you get 3 as a final answer. And for z is d subset d subset over d, which is equals to 4 divided by negative 4. So you get negative 1. So that's it. We're done for the example that using the Cramer's rule method.